Hello students, week 13 physics for grade 12, chapter 40, lesson 3, the nuclear fission reactor, textbook page 812 to 814. At the end of the lesson, you will be able to explain how nuclear fission can be controlled in a reactor. A liter of gasoline can be used to make a violent explosion, or it can be burnt slowly to power an automobile. Here, the example of gasoline is given to say that it can be used to make an explosion, or it can be used to make or give a power for an automobile. Similarly, uranium can be used for bombs or in the controlled way of a power reactor. About 19% of electrical energy in the United States is generated by nuclear fission reactors. A nuclear fission reactor generates energy through a controlled nuclear fission reaction. So if it is not in a controlled manner, that will be like an atomic bomb. So in a controlled way, it can generate electrical energy. These reactors are nuclear furnaces which boil water to produce steam for a turbine. 1 kilogram of uranium fuel, less than the size of a baseball, yields more energy than 30 freight car loads of coal. So if you have a very little amount of uranium, that's enough actually to produce a large amount of electrical energy compared to other fuels. Look at this figure. A nuclear fission power plant converts nuclear energy to electrical energy. So what's happening here? You can see a reactor. The nuclear fission reaction is occurring in this reactor. Then the water is heated. You can see there is a heat exchanger. So water will become a steam, and steam will go to turbine, and turbine will actually rotate generator, and then the transformer is there to increase the voltage or decrease the voltage produced by generators. And there is a condenser. The steam used to rotate the turbine, and then the remaining water, or you can say the steam or water vapor, can go to the condenser and will be cooled and will be again sent to the heat exchanger. So the same amount of water can be used. Components of a nuclear fission reactor. A reactor contains three main components. As you saw in the figure, first one is the nuclear fuel combined with a moderator, the control rods, and water. So altogether it becomes a fission reactor. The nuclear fuel is uranium. So uranium is used actually as a nuclear fuel with its fissionable isotope uranium-235 enriched to about 3%. Because uranium-235 is so highly diluted with uranium-238, an explosion like that of a nuclear bomb is not possible. So uranium-235 is so highly diluted with uranium-238 to avoid the explosion. The moderator may be graphite or it may be water. Okay, what is the purpose of the control rod? Control rods that can be moved in and out of the reactor control how many neutrons are available to trigger additional fission events. So the control rods are made of a material, usually cadmium or boron, that readily absorbs neutrons. Heated water in the heat exchanger, heated water around the nuclear fuel is kept under high pressure and is thus brought to a high temperature without boiling. It transfers heat to a second, lower pressure water system which operates the electric generator in a conventional fashion. So, what will happen to the waste products of fission? A major drawback to fission power is the generation of radioactive waste products of fission. When uranium fissions into two smaller elements, the ratio of neutrons to protons in the product is too great to be stable. These fission products are radioactive. Safely disposing of these waste products requires special storage casks and procedures, and is subject to a developing technology. So, this is a major drawback of nuclear fission reactor. Waste products disposal has some risks and challenges, but anyway, it is subject to a developing technology. So, the technology is still in progress regarding this. American policy has been to look for ways to deeply bury radioactive waste. Many scientists argue that spent nuclear fuel should first be treated in ways to derive value from it or make it less hazardous. So, they are thinking about to recycle the nuclear waste. If these wastes are kept where they are accessible, it may turn out that they can be modified to be less of a danger to future generations than is thought at present. Okay, there is a question here. What would happen if a nuclear reactor had no control rods? What is the answer? Control rods control the number of neutrons that participate in a chain reaction. They thereby keep the reactor in its critical state. Without the control rods, the reactor could become subcritical or supercritical. A concept check question for you. How does a nuclear fission reactor generate energy? Try to find the answer, and thank you. See you next time.